The last gas law in this section is called the combined gas law. You can see that there's homework listed here for the combined gas law, part of your demands, on page 159. We've already talked about Boyle's law, so Boyle's law is found in the green box, and Boyle's law is relating pressure and volume when we're talking about changes in gases. Charles' law is in the purple box, and Charles' law is relating volume and temperature. In Boyle's law, we're assuming that mass and temperature are constant. In Charles' law, we're assuming that mass and pressure are constant. And if we add Boyle's law and Charles' law together, what we get is the combined gas law. In the combined gas law, it's very useful to compare any sort of change in properties of gases as long as the mass of the gas is constant. So we have combined gas law as P1 V1 over T1 is equal to P2 V2 over T2. If we have one of the variables constant, so if the question were to say volume is constant, then we can eliminate the volume out of combined gas law and use the formula that's left. The first example here says that we have a gas cylinder that has a fixed volume. If it has a fixed volume, what we can do, because we know that V1 and V2 are going to be equal to each other, we can eliminate them from our formula. So the formula that we should start with in this example is going to be P1 over T1 is equal to P2 over T2. The question here is saying that we're taking this gas cylinder that is at a pressure of 652 and a temperature of 25, which means that our initial pressure is going to be 652 kPa, and our initial temperature is 25. We have to add 25 to 273 because our temperature always needs to be in Kelvin when we're doing calculations with gases. What we're doing here is we're heating the cylinder to 150 degrees Celsius. So 150 plus 273 is going to be 423 Kelvin. And what we're looking for is we're looking for the new pressure. Because we're looking for P2, what that means we need to do is we need to get P2 on the top all by itself. In order to do that, we have to get rid of T2. So we're going to multiply T2 on both sides, and we can cross T2 off on the right. So our formula that we have left is going to be P2 is equal to T2 P1 over T1. Now I can sub in all of my numbers, so I have T2 is 423 Kelvin. I have P1 is 652 kPa, and then that is going to be over my temperature, my initial temperature, which is 298 Kelvin. If we do 423 multiplied by 652 divided by 298, we are going to get a final pressure of 925 kPa. Our significant digits here, because we're not looking at temperature, are going to be 3. When you think back to the kinetic molecular theory, if we are heating something and we're keeping the volume constant, the molecules will be moving faster, they'll be banging into the sides of the container more, so it makes sense that the pressure is higher than it was initially. What we need to do first here is pick out all of our variables. A balloon containing helium gas at 20 degrees Celsius. 20 degrees, we have to take it and we have to add it to 273, which means we have 298 Kelvin. It has a pressure of 100 kPa and a volume of 750. That's all of our initial, because it's saying, the second part is saying calculate the volume after it rises. That means we're looking for our V2. Our V1 is going to be 7.5 liters. Our P1 is going to be 100 kPa. And what it's doing is it's rising 10 kilometers, where the temperature is going to be negative 36 degrees Celsius. So we take negative 36 and we add 273, which means we have 237 Kelvin. And then we're taking our P2, which is going to be 28 kPa. So in this situation, I have all of my variables, and what I'm looking for is I'm looking for my V2. In order to have V2 by itself on one side, we initially have to get rid of T2. So we're going to multiply both sides by T2, and then the T2s will cross off on the right. And then we have to get rid of P2. Because P2 is on the top, we have to divide both sides by P2, and then P2 will cross off on the right. Our final formula we have now is going to be T2 P1 V1 over P2 T1 is equal to V2. If you're struggling with the organization of this formula and the rearranging of it, please ask because it is complicated. What I've done here is I've subbed in all of my variables. I have 237 Kelvin multiplied by 100 kPa multiplied by 7.5 liters divided by 28 kPa divided by 298 Kelvin. If you look at the units here, my Kelvin will cancel out, my kPas will cancel out, which means the unit of my volume, the only one left, is liters. What I need to do here is 237 multiplied by 100 multiplied by 7.5 divided by 28 divided by 298, and my V2 is going to equal 21.3. If I go back and look at my significant digits, that's in liters, I'm going to disregard temperature. I have 3 for pressure, 2 for pressure, 3 for volume. So I'm going to keep 2 because my pressure is 2, so I have 21 liters. That's my final answer. This slide is a summary, and I've gotten it from page 158. It's talking about STP and SATP. These values, again, are things you have to memorize. The second point here is talking about pressure conversions. You will do pressure conversions as we move on in the unit. It talks again about Kelvin and degrees Celsius and the concept of absolute zero. Those were all part of Mastery Quiz 1. And then Mastery Quiz 2, we've now discussed Boyle's, Charles, and combined laws. So go rock Mastery Quiz 2.